Welcome to The Explainer. Today, we're going to talk about deploying a secret agent right inside your database. Yeah, we're diving into a really powerful SQL technique that lets you ask way smarter, more targeted questions to get exactly the answers you're looking for. So, let's kick things off with a story. You've probably been in this situation, right? You're lost in this sea of options, looking for just one specific thing. Imagine this kid, Rohan, wandering through a massive, bustling marketplace. He's on a mission. Find the one shop that sells the absolute best extra crispy jalebi. Now, he could ask every single shopkeeper one by one, but wow, that would take all day. There's got to be a smarter way to do this. And then, boom, Rohan has this light bulb moment. Instead of that brute force approach, he's going to be smart about it. He'll do it in 2 steps. First, he identifies the exact suite he's looking for, and then he asks the real question. Okay, who sells this specific thing? And you know what? That exact 2-step logic, that's how we can get way smarter with our own databases.
This clever little technique is called a subquery, and we're going to call it our spy inside the query. Seriously, just picture a tiny query with a singular mission. Go get one specific piece of information and bring it back to the main query. It's all about breaking down a huge, messy problem into these neat, bite-sized missions.
Okay, let's see how Rohan's mission actually looks in SQL. That inner query, that's our spy, right? It dives into the suites table with one job. Find the shop ID for jalebi. Now, let's say it finds a couple of them, maybe shop 101 and shop 204. It takes that list, that little piece of intel, and hands it off to the outer query. The outer query then says, great, now I'll just go to the shops table and find the names for only those IDs. See? 2 simple missions, 1 complex problem solved. Super elegant.
Now here's where it gets really interesting. Our spy isn't just a one-trick pony. Depending on the mission you send it on, the kind of intel it brings back can be totally different. The final report can look very different.
Basically, there are 2 main types of intel reports our spy can deliver. First, you have your single-row subquery. This brings back exactly 1 value, just 1 row, 1 column. Think of it like asking, what is the single most expensive suite? You expect 1 answer, right? So you can use simple operators like equals or greater than. But what if you ask for a list of all the shops in a certain area? Well, now your spy comes back with a list of values. That's a multiple-row subquery. And for that, you need a different operator, like in, to check if something is inside that list.
This is a brilliant example of a single-row subquery in action. Let's say you want to find all the cricket players from the same country as Virat Kohli. So, you send the spy in with a super specific mission. Go to the players table and find the country for the player named Virat Kohli. The spy runs off, does its thing, and comes back with 1 single word: India. Perfect. The main query now has its intel. It then just has to find every other player where the country equals India. Simple, clean, and incredibly effective.
Okay, so up until now, our spy has been pretty independent, right? It goes on its mission, gets the info, comes back, and that's it. But what if the spy's mission changed depending on what the main query was looking at? This is where things get really cool. Our spy goes from being a simple messenger to a full-on undercover agent.
This advanced technique is called a correlated subquery, and the key difference is huge. A normal subquery, it runs 1 time, period. A correlated subquery, our undercover agent, is totally different. It's constantly talking to the outer query. For every single row the main query processes, it runs again, sending back a brand new custom report just for that row.
Okay, let's look at a classic example. We want to find every single match where a player scored more than their own personal average. Now you'll see we're using these aliases, M1 and M2, to refer to the same matches table. And this is absolutely crucial. Here's how it works. The outer query, M1, picks up a row. Let's say it's a match where Virat Kohli scored 122 runs. It then turns to the inner query, our correlated subquery, and says, hey, for this player, what's his average score in the M2 table? The inner query calculates Kohli's average and sends it back. Then the outer query checks, is 122 greater than that average? Yep, cool, that's a result. Then it moves to the very next row and does the whole dance all over again for the next player. It's a really powerful row-by-row investigation.
This kind of power naturally brings us to one of the biggest debates in SQL, the showdown. When do you use a subquery, and when do you reach for its famous, often more powerful cousin, the join?
I think the analogy holds up perfectly. A subquery is like sending a messenger to get a single piece of info. Hey, go get me the price of bread. A join is totally different. That's like inviting the baker and his entire staff to your table to combine all your information into one giant spreadsheet. A subquery is for filtering, a join is for combining.
So, what's the bottom line? Well, you're looking at a classic trade-off. Subqueries are often way easier to read. The logic is all nicely wrapped up. It just makes sense. But 9 times out of 10, joins are going to be faster because databases are built to optimize them. So, the real question you have to ask yourself is, what do I need in my final result? If you only need columns from your main table, and you're just using the other table to filter, a subquery can be really clean. But the moment you need columns from both tables in your final output, yeah, you're going to need a join.
All right, that was a whirlwind tour of SQL Spycraft. Let's do a quick mission debrief and lock down the key takeaways.
So, think about the tools you have now. You've got your single-row subqueries, perfect for when you need just one specific fact. You've got your multiple-row subqueries for when you need to check something against a whole list. Then there's the heavy hitter, the correlated subquery, your undercover agent for those really complex row-by-row jobs. And maybe most importantly, you now have a framework for deciding between a subquery and a join based on that trade-off between readability, performance, and what you actually need in your results.
But I've got one last secret for you, a final plot twist in our spy story. We've been saying joins are usually faster, and they are, but not always. Modern database optimizers are incredibly smart, and sometimes a well-written subquery, especially with in, can actually outperform a complicated join. So what's the real takeaway? What's the ultimate rule of data spycraft? It's simple. Test everything, never assume. The only way to know for sure is to measure. So there you have it. You're now armed with some serious SQL spycraft, ready to write smarter, more elegant queries. And that leaves us with just one final thought for you. What's the most complex, the most tangled, the most "I can't believe I got this to work" query you've ever written? We all have those war stories. Think about it. Until next time, keep on explaining.